welcome to our second tutorial in our series on polynomials. This is Mr. T, and we are going to today be talking about solving polynomial equations by factoring. So in our last lesson we spent a lot of time talking about all the different ways that we can factor quadratics and polynomials, and you might be wondering, why bother? Well, the key reason that we want to do that is it's going to allow us to solve some fairly complicated equations. So let's get started. Before we get into our process here, let's think about a simple equation here where we have a times b equals 0. Now, what do we know about, now a and b are real numbers here, so what do we know about a and b if we multiply them together and equals 0? That must be true. So let's maybe make a table here and look at some values. So let's have 3 columns, so values for a, values for b, and the product. And let's explore some values. Let's say a is 2, and we know a times b is 0. What does b have to be? Well, if we substitute in 2 for the a, we get 2b equals 0, or b equals 0. So b had to equal 0 in this case. Let's pick a number for b. Let's assume b was -3. And we know our product equals 0 because that's defined here, so we would get -3a equals 0. So in this case, a has to be 0. Maybe a is a fraction, so let's say here at 1/2. So 1/2 b equals 0. We would multiply it by the reciprocal, and we get b equals 0. Let's see the last example. Let's look at, let's see, what if both a and b were 0? What do you get if you multiply 0 times 0? Well, you get 0, so that's a solution too. So the thing that's common here, for this equation to be true, either a or b or both must equal 0. Now this may seem obvious to you, but it's one of the most important properties that we have in algebra. It's called the zero product property. Which states if you have two real numbers that are multiplied together that equal 0, then at least one of them must equal 0. So let's look at how this helps us to solve a polynomial equation. So let's put a simple problem here. Let's say we have x squared minus x minus 20 equals 0. Now we're looking for values of x. It may be 1, it may be more, that make this true. You could guess and check, but you're probably not going to, you may not have great success, but we could factor this. We just learned how to factor this. So let's find a pair of numbers that multiply to be -20 and add to be -1. So that would be -5 and 4. So we could factor this into x minus 5 times x plus 4, and that equals 0. Now this is where our zero product property is going to come into play. This expression represents some unknown number, so let's call that a. And this represents another unknown number. Let's call it b. They're multiplied together, and they equal 0. So we just learned from the zero product property either a, which is x minus 5, must equal 0, or b must equal 0, which is x plus 4 equals 0. Now these are two simple linear equations, and so we can solve here x equals 5 and x equals -4. So we have two solutions here that if we plugged back into the original equation would make this true. Let's check that out. So we have 5 squared minus 5 minus 20 equals 0. So we have 25 minus 5 minus 20 equals 0, and that checks out. And if we do negative 4 squared, now here if you're doing that in the calculator, we've got to be careful with these negative signs. Negative 4 squared is 16, minus a negative 4 is plus 4, minus 20, so we have here 20 minus 20, and we get 0 equals 0. So the zero product property allows us, if we can factor a quadratic equation that equals 0, we can then just set each factor equal to 0 and get our solutions. So let's look at some other examples here. Let's look at 6x squared plus 5x minus 6 equals 0. So again, we want to try to factor this. So let's use that a times c method here. So a times c is 36, and we're looking for a pair of negative 36. We're looking at a pair of numbers that multiplies to be negative 6 and adds to 5, so that's going to be negative 4 and 9. So remember, we rewrite our middle term. We group. GCF factor each group, so I can pull a 2x out here. And here I can pull out a 3. And we can pull that together using GCF factoring again. And now we have two things multiplied together that equal 0. So we know that either 2x plus 3 has to equal 0, or 3x minus 2 equals 0. So if we solve this, we would be subtracting 3 and divide by 2, so we get x equals negative 3 halves. And here we're going to add 2 and divide by 3, so we get x equals 2/3. Now the chance of solving this equation here by guess and check and guessing those fractions is very small. But as you can see, if we're able to factor something, so our factoring skills are important here, we can easily solve the problem. Let's look at two more examples. Let's look at here one where we're going to use a difference of two squares factoring and also a combo factoring. So let's look here at 3x cubed minus 27x equals 0. So we can GCF factor out of 3x. This is now a difference of two squares, so that factors into now the zero product property extends to having three multiples, so at least one of those things has to be 0. So we just do the same thing. We set each factor equal to 0 and solve each one. So here we get x equals 0, here we get x equals negative 3, and here we get x equals 3. So for this problem we had three solutions. Our last problem here has a little bit of a trick to it. It's to make sure you understand our process here. So we have an equation. Now I'm going to, just as a warning, I'm going to do this incorrectly here, but let's talk about why it's incorrect. So in the last problem we factored this, so this factors into x plus 3 times x minus 2 equals 14. But there is no property that tells us if you have two things that multiply 14 to narrow down what these could be. There's an infinite number of combinations of numbers that multiply to be 14. We can't say that one or other of these factors has to be a particular number. So to do our solve by factoring, so we don't want to do that, the key thing is we must make this equal to 0. So we must make the polynomial equal 0. So before we do what we just did, we want to, let me erase what the incorrect work here. We want to make it equal to 0, so I can subtract 14 from both sides. So now we have x squared plus x minus 6 equal, it's not minus 6, minus 20 equals 0. Now we can factor, so now we're going to get x plus 5 and x minus 4. So if we set each of those factors equal to 0, we get x equals negative 5 and x equals 4. So the whole power of factoring, and especially if you're good at it and quickly, is it allows us to solve these quadratics, and in the last example, a polynomial here with degree 3, very easily. We did all this without the use of a calculator. And the one key thing here, just so you don't get burnt on some problems, make sure it equals to 0 first. Move everything in the equation to one side. Even if we had something like here, this problem had been x squared minus 6 equals 14 minus x. You know, to solve this, we've got to move everything to the other side. Move the x over here, subtract the 14. And then again we would have had, so don't forget this is important, otherwise this is pretty easy, and good luck as you work your problems.